Hello everyone and welcome to today's video on Numpy at Intellipaat. Numpy stands for Numerical Python, which is a powerful library for scientific computing in Python. It provides support for efficient and multi-dimensional arrays, along with vast collection of mathematical functions to operate on these arrays. Numpy is widely used in various domains such as data analysis, machine learning, and scientific research. By leveraging the capabilities of Numpy, developers can perform complex mathematical operations, manipulate large datasets, and also optimize their code for improved performance. In this tutorial, we will explore the fundamental concepts of Numpy and discover how it can enhance your data analysis capabilities in Python. Now before we move on and learn more about Numpy, do not forget to hit the subscribe button and click the bell icon. So first, we are going to start our session with what is Numpy. Moving ahead, we will discuss the installation of Numpy. Then, we will have a thorough discussion on Numpy arrays. And at the end, we are going to conclude our session with advanced Numpy operations. So let's start with what is Numpy. Do you know, friends, that Numpy is short for Numerical Python, which is a powerful library for scientific computing in Python. It serves as a fundamental building block for various scientific and data-intensive applications. Numpy provides supports for efficient and multi-dimensional arrays along with an extensive collection of mathematical functions to operate on these arrays. The core component of Numpy array is the ND array or the nth dimensional array object, which basically allows for efficient storage and manipulation of homogeneous data. Unlike Python built-in list, Numpy arrays are contiguous in memory, thus enabling faster execution of operations. The ability to perform vectorized operations on arrays makes Numpy highly efficient for numerical computations. Numpy offers a wide range of mathematical functions for tasks such as linear algebra, statistics, Fourier analysis, and many more. It provides tools for array manipulation, including reshaping, slicing, indexing, and concatenation. With Numpy, complex mathematical operations can be expressed concisely and executed efficiently. In addition to arrays, Numpy also provides functionalities for random number generation, polynomial handling, and integration with other libraries like pandas, matplotlib, and scikit-learn. Its seamless integration with these libraries enables efficient data manipulation, visualization, and machine learning tasks. Numpy's performance benefits extend beyond its optimized array operations. It also offers memory-efficient arrays, broadcasting capabilities, and universal functions that operate element-wise on these arrays, thus eliminating the need for explicit loops. This allows for faster execution of computations and facilitates writing clean and concise code. Overall, if I have to say that Numpy is a vital tool for scientific computing and data analysis in Python. But the question arises that why should we use Numpy? Actually, Numpy offers several key advantages that makes it a preferable choice for scientific computing and data analysis. Here are some of the reasons. The first one is efficient array operations. Numpy provides a powerful n-dimensional array object, an ND array, which allows efficient storage and manipulation of homogeneous data. It offers optimized mathematical functions and operations that can be applied element-wise on these arrays. These vectorized operations significantly improve performance compared to traditional Python lists. Second of all is memory efficiency. Numpy arrays are densely packed in memory and allow for efficient storage of large datasets. They consume less memory compared to Python lists, which leads to improved performance and enables handling of larger datasets. Then comes is mathematical functions. Numpy provides a vast collection of mathematical functions for linear algebra, Fourier analysis, random number generations, and many more. These functions are optimized for efficient execution and provide a solid foundation on scientific computing tasks. I hope so, guys, you would have had a clear idea that why should we use Numpy. So let's start the installation of Numpy. We will be using Google Colab for our hands-on for understanding the Numpy operation on arrays and various other things. So let's move on. So guys, we are using Google Colab for our Numpy hands-on. So let's install the Numpy. So Numpy is a library. For that, we are using pip. So on your Google Colab, just type pip install Numpy. Okay. Then go on import numpy as np, and I have initialized an array as numpy array. np.array is the syntax, and in which I have to give the parenthesis, and inside this I have the square brackets, and I have initialized our array as 1, 2, 3, 4 and 5. Very simple. Then I want to print this array. So simply I have applied the function print. Then I want to know the type of the array. What is the type of this array? So basically the first output, as you can see all over here, it shows 1, 2, 3, 4 and 5. Okay, same as it returned. And then if I try to print the type of it, it's showing class numpy.nd array. So basically it's a numpy array what we have initialized. So I hope so guys, you would have got a brief idea of installation. So this is Google Colab, one of the best IDEs for performing machine learning operations. I would recommend you to go for this. Otherwise, you can go for Jupyter, which is also an awesome IDE. Now let's move on and understand the next parts. Okay guys, so we have to check the version of our NumPy which we are using. So what you can do, you can just type print np./version, then again double space bar. So this actually completes our version. So you can just, if you click on this, so it's going to print it. So let's try it. As you can see, the version of our NumPy which we are using is 1.22.4. So this is one important thing which you can just always check it out, the version of the NumPy which you are using. Now let us move to the another part, that is creating arrays. So first of all, what you have to do guys, you have to import numpy as np. Then you have to initialize your array. Here I have given the name arr and I have initialized it with np.array. Then inside these parentheses, I have given these number 1, 2, 3, 4 and 5. You can give any number. So let's change the data here. Suppose if I say it's 3, 2, 8, okay, and 9. So I have changed my data and I want to print the array and what is the type of the array. Okay, so as you can see when I'm going to click on this, so it says 32985 and the class is numpy.nd array. I hope so guys, you would have got a brief idea. Similarly, if I say import numpy as np, I have imported our numpy array. Okay, then I have initialized our array as np.array and I have added one more number. So if I print it, you would have guessed right. It will just show this output here. So it is 1, 2, 3, 4 and 5. So it's pretty clear that what we want to achieve is by creating an array means you have to always use np.array. I hope so guys, it's clear to you. Now let's move on guys and study the dimension of arrays. As you can see all over here guys, that this array equals to np.array. This is a single dimensional array, or you can say 1D. Then in this you can say the array has been initialized. There are two square brackets. One is ending, enclosing all these elements. The first one is 1, 2, 3. Second is 4, 5, 6. And the third one you can see there are two closing brackets. The first the green one, second the brown one. And then each of the elements 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 again in the blue bracket. This denotes that these are the 3D elements. Now let us visualize these. Okay. Now if I say import np as np, array equals to np.array, and I want to say print array. Let us see what will be the output. So as you can see guys, we are getting the output 42. So there is just one only element in this array, that is 42. Okay. Now let us initialize the dimension of each of these. So say I have used this x equals to np.array 42, np.array 1, 2, 3, 4, 5, then z equals to square brackets, there 1, 2, 3, 4, 5, 6, and the brown one enclosing 1, 2, 3 and 4, 5, 6. Then there is a w array, okay, in which I have these elements 1, 2, 3, 4, 5, 6, 1, 2, 3 and 4, 5, 6. And for finding the dimension, I have used the variable name x and calling the endim. So when we are going to type x.endim, it's gonna return the dimension of our array. So let us see what are the dimension of our array which we have initialized with x, y, z and w. So as you can see, x is a 0 dimensional element because there is no parentheses all over here. Second one is 1 dimensional. Z1 is 2D. As you can see, there are two square brackets involved. As you can see, there are 3 square brackets involved which basically denotes that this is the third dimension. Now let's move on and understand some of the more metrics of these dimensions. Suppose we have this code, import numpy as np, and array equals to np.array 1 2 3 4 5, and inside this parenthesis I am saying ndim equals to 5. Now I'm printing our array, and I'm also printing the number of dimension by calling array.ndim. Let us see what is our output. So as you can see, I want to create this array as a fifth dimensional array. So how do you count on these one? It says 1, 2, 3, 4 and 5. So 5 square brackets means 5 dimension. So basically what we have done all over here with this array, we are transforming this into 5 dimension. And I wanted to print the number of dimension, so I'm calling this array.ndim, which we have used this syntax all over here, as you can see guys. So in order to initialize your dimension, you could just type ndim and your array would be initialized in that dimension. Suppose I say I want to initialize in this third dimension only, and if I run it, you would see that our dimension is now changed. Similarly, if I say 2, so you would be able to see that our dimension is changing to 2 dimension. And similarly, if I want to initialize it as 1 dimension, so it would be initialized as dimension 1. I hope so guys, you would have got a brief idea regarding how to change the dimension of your array, how to initialize your array with the required dimension. And if you want to print the dimension of your array, you have to call the name of your array with this .ndim. Okay guys, I hope so you would have got a brief idea about creating an array. Now let's move on and understand about array indexing. So guys, array indexing is same as accessing an array element. You can access an array element by referring to its index number. And the indexes in the NumPy array basically starts with 0, meaning that the first element of the index 0 and the second index is 1. Now let us see our code, in which we have import numpy as np and array equals to np.array 1 2 3 4, and I'm printing the index of array 1. So tell me guys, which element would be printed from this? You can pause the video and then check the right answer. So let us run it. So it says 2. So our indexing basically starts from the first element has been indexed to 0, next one is 1, third one is 2, and the fourth one is 3. This is the order of indexing which is followed in NumPy, and basically it is done in arrays also. Now let us see and understand accessing the elements of a 2D array. So suppose we have our array equals to np.array, then 1 2 3 4 5 and 6 7 8 9 10. And I want to print the second element on the first row. Okay guys, so basically this array would be initialized as a matrix. So guys, we are printing the second element on the first row. And I would advise you to make this array as a matrix form in your pen and paper, then you could try to find out the answer. So in the second element in the first row means it would be a matrix, and I'm printing 0 1. So initialize the matrix and then you could do the indexing for the same. So you can just pause the video and guess for the answer. So guys, our answer is the second element on the first row is 2. Okay, so how this answer came up, basically what you have to do is consider something like this. So this is our column, basically the rows. So there are 2 rows. The first one is the 0th row and the second one is the first row. So I want to access the second element on the first row. So means the first row would be this. So in this I have to do again indexing, which is 0, 1, 2, 3, 4. So this first element is 2. So that's why it's printing 2. So suppose if I would have typed something like 3. Guys, so can you guess the answer guys right now? Just pause the video. So you would have guessed rightly. The answer would be something around 4. Let's see. Okay, we have guessed it rightly. Now suppose if I say I have changed the value as 1 and then 3, then what we have to do? This means this is our second row and I'm accessing the third element in this. So let's start our indexing 0, 1, 2 and 3. So our answer would be 9. Let's run it. So the second element on the first row is 9. I hope so guys, you would have got a brief idea about how to access element in the 2D array. So now guys, we have the third dimensional array, and let's see how we are accessing our element. So guys, this is our 3D array. So in this 3D array, what we are seeing this, it's saying print array 0, 1 and 2. So how we are basically accessing our elements. So 0 denotes, suppose all we have here, so there are 3 brackets all present all over here. So let's name it with that 0, 1 and 2. Okay. So now as you can see, how many brown brackets are there guys? So there is 2 brown brackets. So we can index it something like it as 0 and 1. So 0 denotes the elements containing 1, 2, 3 and 4, 5, 6. Whereas 1 denotes the element containing 7, 8, 9 and 10, 11, 12. Okay guys, I will repeat again. So as you can see, how many brown brackets are there guys? This denotes there are 2 brown brackets present all over here. And inside the brown brackets, we have 2 blue elements. Okay, 2 blue brackets. Okay, as you can see, the first blue bracket is 1, 2, 3 and then is 4, 5, 6, which is included in 0th brown bracket. Then in the first brown bracket, we have 7, 8, 9 and 10, 11, 12. Now it's saying 0th. So means the 0th brown bracket is this one. Okay. Now I am saying that it is saying 1 and 2. So 1 means this element which is 4, 5, 6. So we can index it something like it has 0 and then it has 1. So 1 is 4, 5, 6. Then it's saying the second element in this. So let's index it 0, 1 and 2. So our answer would be 6. Let's print it. Okay. Now it's right. Now let us change something. Suppose we say 1, 1, 2. So guys, you can pause the video and then you can guess for the answer. So let us see what will be the answer. So it's saying 1. So this brown bracket is saying 0 and this brown bracket means 1. So in this 1, I have to select the first element. First element would be 10, 11, 12. And I'm choosing the second index, 0, 1 and 2. So I hope so our answer would be 12. Let's see. We have guessed it rightly. Let's try one more modification guys. Suppose if I say 2, 1, 2. You can pause the video guys and check for the answer. Okay, so as you can see guys, we are getting an index error because there is no another element of brown present all over here. Okay, there are only 2 brown brackets. The first one is this, which we are saying at index 0, and the second one is this one. Okay, so that's why it would be an index error. So the dimension is about this one is, this is the 0 and 1. Okay, so don't do any mistake regarding this. This was just a clickbait for you. Now let's move on and understand the next concept, or accessing the negative elements. So suppose we are having a negative indexing. So what we have to do guys, same concept would be applied. So as you can see, our array has been initialized as np.array as 1, 2, 3, 4 and 5. Then we have 6, 7, 8, 9, 10. Okay. So similarly it says 1 and then it's saying -1. So means this would be 1, this brown bracket containing 6, 7, 8, 9, 10 and it's saying -1. So I hope so it means that the last second element from the second dimension. So let us print it out and see what will be our output. So it's saying the answer would be 10. So as I have told you all rightly, that in order to see the elements, this is the right way of indexing. So this is 0, 1, 2, 3, 4. And if you are going backwards, means that -1, -2, -3, -4 and -5. Okay, now let us do some modification in this. So guys, what if I say if I add -1 in this, so will our output will be there? So it's saying again our last element from second dimension is 10. This is pretty interesting. Let us see it as -2. So it's saying 9. Okay. So if I say -2 and -2, guys, you can pause the video. Okay. Then check for the answer. I hope so guys, you would have got a brief idea regarding how to access a negative element or how to do the negative indexing. Okay. Now let's move on and understand about array slicing. So guys, there are 2 ways to do it. The first would be syntax something like this, starting to end, and then you might get some other time starting, end, and there will be a step. So let us see this one. It says that array np.array 1 2 3 4 5 6 7, and then we are printing 1 to 5. Let us see. This means this is the starting and this is the ending. So we are starting from index 1 where it is 2 and the ending is 5. So 0, 1, 2, 3, 4 and 5. Okay. Now as you can see, the element 5th is not included. We are just only printing the elements in between. So we are counting our starting element and excluding the end element. So if I say 1, 2, 6. So what would be printed, guys? So we will be starting from 2. Okay. So index 1, 2, 3, 4, 5. Okay. So till 6 it would be printed, guys. Let's see the output. It's pretty much clear. So if I say it starts with index 0, then what will be included? Then the 0th element will be included. So which says 0, 1, 2, 3, 4, 5. Till 6 would be there. It's pretty simple, guys. Now let us see something like this. So what if we have to slice it 4th ... then there is a parenthesis. And our array is being initialized as an NP array. So if I just click on this, you would see it's just printing 4, 5, 6. So let us index our elements first. So this is 0, 1, 2, 3 and 4. So 4th element is 5th. So from 5th, all the elements present in our array basically are printed, and including the first one. So 5, 6, 7 are printed. Suppose if I would have said 3, so it would have printed from the elements till 4 to the end. Okay, so this is one of the convention of doing it. You would have definitely done in Python about these syntax would have come in list. So this is similar to that. Now let's move on and understand this one. So it's saying now the problem is that here the first element was there, then the double two semicolon dots were there. Now the double two dots are coming before and then the element is present, which is 4 or any number. So if we click on this, we would find out that it's printing the elements till 1, 2, 3 and 4. So 0, 1, 2, 3 and 4. So as you can see, the 4th element has been excluded. We are printing the elements just before the end element. So suppose if I say it would have been 5, then the 5th index element would have been excluded. So 0, 1, 2, 3 and 4. Okay, the 5th index has been excluded. Similarly, if we go for 2, so you could guess the answer. So we will be printing something like this: 0, 1, then 2 would be excluded. So we will be just printing 1 and 2. Okay guys, I hope so guys you would have got an idea about this kind of indexing. Now let's move on and have some negative indexing. So guys, there is an array np.array and we are just doing something like this: print array -3 is to -1. So our syntax says this is the starting and this will be the ending. So as you can see guys, if we go from negative indexing, this is -1, -2 and -3. Okay, so this is -3, so we'll be starting from 5th till -1, means this would be excluded. So we just will be printing 5 and 6. Let us see the answer. Okay, so our answer is right. It is 5 and 6. Very simple guys. Now let's move on and have some other syntax which is including the step. So it's saying that we have to print the element from starting to the end 1 to 5 and then we want to have a step of 2. So if you print this, you would find out that we are just printing 2 and 4 and the 3 is excluded. So what's the logic behind this is guys? So we are starting from 2, okay, until 5. So there's a difference of two elements. So as you can see guys, when we are printing this, it's printing 2 and 4. So our step is 2, which means that we have to reduce by element or skip the element by 1. This is one common syntax which you can follow. So we'll start with our index 1, which is 2. Then we will leave this 3, which is at index 2. Then there is another element called 3, which is at 4. Okay guys, then this is at 5. So we are basically skipping this element 5 also, and then there it comes 6. So what are the elements left all over here, which is 2 and 4. So let us try with some other element guys. Suppose if I say it has 3. So you could guess the answer. It will be 2 and 5. How guys? Let's try to figure it out. So we will be starting with our index 1, which is 2. Okay. Now this is step is 3, which means that we have to skip the 2 elements in a go. So we are counting from 2, then we will skip the 2 elements, which is 3 and 4 of index 2 and 3. Then another element comes 5, okay, which is at index 4, okay. Then the fifth element is 6, which will not be included. So we are just printing 2 and 5. Similarly, if I say there is a step of 4, so guys, what would be the answer? So means we have to skip the 3 elements, 3, 4 and 5, okay. So our answer would contain just one element. Similarly guys, this would have been very easy for you to understand how many elements we have to skip. So step means if the step is 4, which means that we have to skip 3 elements. If the step is 3, which means that we have to skip the 2 elements in between. So I hope so guys, you would have got an idea how to find the answer when this step is involved. Now let's move on and try to understand this kind of slicing. It says array double dot 2. So if I print this, you would find out we are just printing 1, 3, 5 and 7. So it is kind of an odd number series which you will try to find out. So basically if I say it has 3, so guys, what will be the answer? So just printing 1, 4 and 7. So in order to give the exact differences of element, how much you want to print it up, it's gonna print the same. So similarly, till 3 means it says to the all elements present in this series. So there is a double dot for the same. So suppose if I want to just type this, so it prints basically the entire array. So if I just give the step as 3, means there is the gap of 3 present in this all the series. So basically 1, 2, 3, okay. 2 and 3 are excluded, okay. This is step 3. So this is the same process which we have to follow, what we have learned. So 3 means 2 elements would be skipped. So we are starting here from index 0 basically, because nothing is written. So it will consider it as 0th index, okay. Then the step is 3, which means that 2 elements would be skipped, 2 and 3. Then comes 4, again 2 elements would be skipped, which is 5 and 6, and their answer is 7. Now suppose if I say 1, so how many elements we have to skip? So it will print the entire, because from the 1 difference you could see there is a 1 difference or step of 1 in all these elements. So it is negligible. So we have to start from the step 2. I hope so guys, you would have got a brief idea about what this syntax means. Okay. Now let's move on and understand this kind of slicing. So suppose we have our 2D array, okay, and we are printing array 1 and 1:4. So how will you figure this out? Okay, now we have to first understand, first means that it is this row, okay, 6, 7, 8, 9 and 10. And here I am printing the elements from 1 to 4. 1 means we have this from index 7 till 2, 3 means 7, 8 and 9 would be printed. Let's try to find out the answer guys. So as you can see here, the answer is 7, 8, 9. So suppose if I would have said 1, 2, 3, so what would have been our answer? It says 7 and 8. Very simple. I hope so guys, you would have got this idea. Same concept, just the dimension has been involved. Now let's move on and understand about this one. So I am saying 0:2 and then is 2. So guys, how would you find the answer for the same? So guys, this is pretty interesting question. So it says import numpy as np, array equals to np.array, and we have this 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10 as an 2D array. Now it's saying to print array 0:2 and then 2. And we are getting the answer as 3 and 8. So what is the logic behind the same? The logic is pretty much simple. So 0 to 2 means the array, we have to include the 0th array and the first array and the second column of each one of this. So we have to include the element from the first and the second. So this is our row 0 and this is our row 1, and in which I have to collect the second element from this and this. So our answer would be 3 and 8. So let's start with this. So we have to select this row and then we have to select this row. So in this row, we need the second element, which is it 0, 1 and 2, which is 3. And the second element of this would be 0, 1 and 2, which would be 8. Now suppose if I say 3, okay, so what would be the answer? So every third element, which is 4 and 9. Similarly, if we go for this question, here we have an 2D array, and now I am just making this little bit much more complicated just by typing 0:2 and 1:4. The first one denotes we have to select the 0th row and the first row. And I have to choose the element from all these, the columns, starting from 1 to 4. Means the element in this would be included 2, 3 and 4. Okay guys, and here would be 7, 8 and 9. So our answer would be somewhere around 2, 3, 4 and 7, 8, 9. Let's see. Okay guys, we have got this answer. So it means that we are including those column names starting from index 1 till index 3. Okay, this is 1, 2 and 3, and here it is 1, 2 and 3. That was it for indexing guys. I hope so you would have got a brief idea how to do array indexing in NumPy. Now guys, this is something very interesting. Now we have to find the difference between copy and view. Actually, the main difference between copy and view of an array is that copy is kind of a new array, where view is just the view of an original array. Copy owns the data and changes made to the copy will not affect the original array. But any changes made to the original array will not affect the copy. And the view does not own the data, so any changes made to the view will affect the original array. I hope so guys you would have got the idea. Let us see these codes. So here we have an array 1, 2, 3, 4, 5, and I am just copying this array as x equals to array.copy. And I am trying to change the element array 0:2. Now I am printing the original array, and here I am printing the new array. Okay guys, as you can see, x is our copied array, which is same as the original array, but array of index 0 we have changed it to 42. So now when we are printing our array, it is showing 42, 2, 3, 4, 5. So this is how copy works. Similarly, if I go for the view, as you can see here in the view, here we have array as np.array 1, 2, 3, 4, 5, and I am creating a view of x, and I am changing array of 0 equals to 42, and now I am printing array and our view. Here as you can see, we are getting the same elements 42, 2, 3, 4, 5, 42, 2, 3, 4, 5, which is same. So the basic difference between copy and view is in the copy, as you can see guys, the elements of the copy is not changed when we are changing the original array. But in view, as you can see, if you are changing the elements of the array, the view is also changing. This is the major difference between copy and view. Now guys, let's understand the shape of the NumPy array. So guys, the shape of an array is the number of elements in each dimension. In order to get the shape of an array, we have an attribute called array.shape. Okay, so whenever we are calling this, we are going to get the number of elements in each dimension. So if I just click on this, it is showing 2 and 4. So means there are two two-dimensional elements, okay, and there is 4 elements on each one of them. So as you can see, the brown brackets are 2, okay, this is the first one and this is the second one. Means how much of the rows we have, okay, and how much elements do we have in each of the rows? We have 4 elements, 1, 2, 3 and 4. So basically it returns the dimension. Suppose if I change 4 here and reduce something like this, okay, so what will be our output guys? So now as you can see, our output would be something around, as you can see, we have 2 brown brackets, okay, so answer would be 2, but the elements inside each of them is around 3. So our elements would be 2 and 3. This is our dimension of an array. This is basically the shape of our array. Now guys, let's understand the reshape. Okay, so guys, here we have array np.array, which is a single dimensional array of including 1, 2, 3, 4, 5, 6 till 12. And now I'm shaping this. Here we are doing array.reshape 4 or 3. So this means here, if we go to the shape function, so as you can see guys, 2 denotes the number of brown brackets all over here. So inside this single green bracket, how many brown brackets would be there? It says 2. So similarly here, the number of brown brackets present would be 4, or means these brackets, the small ones, inside the bigger one. Okay. Now I want to add 3 elements each. So 1, 2, 3, okay. Then again 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is how we are reshaping a single D, 1D into 2D. Now let's go on and understand this. Import numpy as np, array np.array 1, 2, 3, 4, 5 till 12. Now I am reshaping it from 1D to 3D. Let us see what will be the output. So as you can see all over here, we have 1, 2, 3, 4 and 5, 6, 7, 8, 9, 10 and 11, 12. So we can categorize something like this. So it says that what will be the number of smaller brackets. So 3 means the 3 small brackets, which we denoted as the brown brackets. Okay guys, so in this, how many of you want the number of this outer 2 brackets? That would be 2. Okay, 3 means the 3 elements composing these, and 2 denotes the number of elements inside these smaller ones, which is 2 elements. So guys, we can check this something like this. 2 denotes the number of this bracket, which is here I am pointing it out. This is first. Okay. So as you can see, how many of the brackets we want? So there is 1 of this and 1 of this, which is 2. Now, how many of the smaller one we want? Something like this. Okay. This is 3. So 1, okay, 2 and 3. Similarly, 1, 2 and 3. Then how many elements we want to put inside? This is 2. 1, 2, 3, 4, 5, 6. Now suppose if I say I want it as somewhere 3. So what would be the output? So here we are getting the value error because we cannot reshape array of size 12 into this shape. Okay guys, this is not possible. So you have to always check for the indexing. Okay. What suppose if I say 1? So as you can see guys, here we are getting the value error. The perfect combination for this to shape this would be 2, 3, 2. Because the number of elements is 12, and if we multiply all these 2 into 3 into 2, then our combination would perfectly set up to 12. Okay guys, so there is a value error for the same. So you have to put these values in order somewhere that the multiple comes around 12. I hope so guys, you would have got an idea about reshape function. So here we have transformed our single D array into 2D array, and here 1D into 3D. Okay guys, now let's go on for array iteration. So in the array iteration, all we have all over here, we have an array np, and this is np.array, and here we are just going through each of the elements 1, 2 and 3. So guys, as you would have seen for loop, similarly iteration here is similarly. For using the for loop, we are just iterating over the elements or moving to all the elements in the arrays. It is pretty simple. So let us print the output. So we are just printing 1, 2 and 3. Basically all the elements. Now if I go to the 2D element, for x in array, print x. So basically we are going through the rows. So how many rows we have? We have this 2 rows. So first is printing 1, 2 and 3, and second it is printing 4, 5 and 6. Now if I have to print all the elements inside this, then I have to provide one more for loop. So as you can see in this example, for x in array, for y in x, print the y. Okay, now we'll be just printing the elements, which is 1, 2, 3, 4, 5, 6. Let's understand this loop. For x in array means we are going through the rows. And for y in these rows, I am printing each of the element in these rows, which is 1, 2 and 3 and 4, 5 and 6. Similarly, as we go down the side, we could see we have the 3D array. Now I am printing the number of rows, which would be these 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12. Let us see the answer. Okay. So as stated, we are printing the number of rows all over here. So we have just 2 rows in this array. Similarly, if we go down and we could find out if we want to print the element inside each one of them, then I have to use the 3 loops, which is x, y and z. So then only our elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be printed. Now let's move on and understand the another logic, which is using of np.end diter. So this is a function. So as you will click all over here, so you could see something all over here. The parameters, what is the efficient multi-dimensional iterator object over arrays. Now as you can see guys here, we are using np.enditer function. What is this function all about? This function basically is a helping function which is used from very basic to very advanced iterations. It solves some of the basic issues which we face in iteration. So if we go for loops and iterating through each of the scalar of an array, we need to use n for loops, which can be difficult to write with a very high dimensionality. Now suppose if we have a very high dimensionality present in our array, then this function is going to be very smoother and helps to solve our problem. Now suppose how this is done. So as you can see in this code, we have written import numpy as np, array equals to np.array, then we have this 1, 2, 3, 4, 5, 6 and 7, 8. So for x in x, np.enditer print x. So what would be the answer guys? You can see guys, it's basically printing all the elements of this array. So for x in np.enditer, and we are traversing through this array and we are printing all the elements of this array. Similarly, if you go in this for loop, the for x in np.ir, then we are printing array flags equals to buffered, opd types equals to x, and we are printing x. What would be the answer guys? It is showing b1, b2 and b3. So as you can see in this code, it is using a numpy to create a one-dimensional array. So the given code is basically using numpy to create one-dimensional array, and then it is iterating over its element using np.diter function. So here is a breakdown of the code. As you can see guys, this function has created the array. Then for x in np.diter, array flags equals to buffered and opd types equals to yes. So basically this line starts the loop, then it iterates over the elements of the array using the np.enditer function. So the np.enditer array function is used to iterate over the array R where flags equals to buffered. The flag parameter is basically set to buffered to enable buffering of the iterator. Buffering improves the performance by reducing the number of memory access operation. And here opd types equals to s. The opd types parameter is set to s to specify the data type of the output elements. In this case, it is set to s for the string data type. Here print x prints it, and the code will print the following output b1, b2 and b3. This means that it iterates over each element of the array and prints them as the b types of the object with the b prefix. Since the opd types parameter is set to s, the elements are treated as string in this case. I hope so guys, you would have got a brief idea. Then let's move to this code which says import numpy as np, array equals to np.array, 1, 2, 3, 4, 5, 6, 7, 8, and for x in np.enditer print x. So there is an array operation of dot dot and this here. So let's find the output. It prints 1, 3, 5, 7. Let's find out how this answer comes. So basically array np.1, 2, 3, 4, 5, 6, 7, 8 creates a numpy array with 2 rows and 4 columns. The first contains the value 1, 2, 3, 4 and the second row contains 5, 6, 7, 8. For x in np.enditer, array dot dot then dot dot 2, this line basically starts a loop that iterates over a specific slice of the array using the np.enditer function. Let's break it down a little bit much more further. Array dot, then it is dot dot double dot 2 is a slice of the array that is being iterated over. It selects all the rows and column with a step of 2, which means that it selects every second column. So np.enditer.this creates an iterator to iterate over the selected slice, and printx prints the current element during the each iteration of the loop. So here the code is going to print 1, 3, 5, 7, which is at the step of 2. So this means it also iterates over each element in the selected slice of the array, which includes the element 1, 3 from the first row, 5, 7 from the second row. The elements are printed one by one during each iteration of the loop. I hope so guys, you would have got a brief idea regarding this. This is a basic operation if you have seen in the earlier how we have printed. So I hope so guys, it would be clear to you how we have performed certain operation on numpy array to a little bit complex to a little bit easier. I hope so guys, you would have got a brief idea about numpy array. So we have understood a vast range of operations and understood about Numpy arrays. That was all for today's video, guys. I hope so you would have enjoyed our today's video on Numpy.
Just a quick info, guys. Intellipaat offers advanced certification in data science and AI in collaboration with iHub Divya Samparka IIT Roorkee. Through this course, you can learn all the important concepts of data science and AI from esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in field of data science and AI.